In the previous video, we did how to find the PDF, one variable that's a function of another of another random variable, like like here. Y is a function of x, and we know the PDF of x. What is the PDF of y? We've gone through that for single random variables. Now I want to talk about where this y could be a function of two random variables, or say a z is a function of x and y. Uh, the general procedure is going to be the same, um, except we're going to get this integrand here is going to be a joint PDF, and we have to integrate over. It'll be a double integrand. So let's do an example. Um, so this r is a function of two random variables, x and y. And this is the case of like a dart throwing problem. X could be the horizontal miss distance and y the vertical miss distance. Now we'll assume that x and y are both zero mean Gaussians and they have the same variance. So you're just as likely to miss as much horizontally as you are vertically, and they are independent of each other, we'll assume. So we're going to need this joint PDF, and since they're independent, it's just a product of the individual PDFs. Since they're Gaussian, we know what they are. So here's the joint PDF. We first want the cumulative distribution function, CDF, of R. And what does that mean? It's the probability that the random variable R is less than or equal to some argument, which means the probability that this function of x and y is less than or equal to that argument. And here's the function of x and y. So it's this probability. What does that mean? We're going to integrate over the joint PDF. And since it's two variables now, it's a double integrate. We're going to integrate it over the region in the xy plane where this is true. And it's going to be a circle. So there's the region. So we want to take this integral. Well, in this case, it's the way to go about doing that is to convert polar coordinates. And then x would be r cosine theta, y would be r sine theta, r squared is x plus y squared. The limits, and then this area of integration, zone of region of integration, is a circle of radius r. So you might not remember how to do spherical coordinates. You had to add this extra r in there. You make these substitutions, add this extra r, and then r will go from 0 to r, and theta goes all the way around, 0 to 2 pi. This is just converting the polar coordinates. I'm not going to go through all this. This is an integral that splits up into a product of integrals. You know, the double integral is just a product of individual integrals. To do this guy, we need to do variable substitution. I'm not going to go through all this, but this is the cumulative distribution function yet as a result of taking and then take this guy's derivative to get the PDF we want. Take this derivative, and you get this function, and that is a Rayleigh distribution, which looks like this. So this would be like your distribution of miss distances when throwing darts, for example. You've got zero probability of a totally precise bullseye. But as soon as you have some little error, you start getting positive probability. Anyway, that's that. Um, I think I'll save this for another second example of the same thing.